Welcome back to the Production Test Fixture series. As a reminder, we're building a production test fixture for this board. If you've not seen part 1 where we did the schematic design, there's a card here to go back and watch it. In this video, we will go over the schematic sign-off process, including how to use KiCAD's electrical rule check system. I originally was not planning on making this video, however, as I was going through the ERC process, there were some things that needed attention that I wanted to share. Since the last video, I've done some cleanup and added a few things to the schematic to get started on finishing it off. The first thing I added is some mounting holes and fiducials. I put these on the schematic so that they don't accidentally get left off or deleted. Anything that is on the PCB, I make sure I have a corresponding symbol in the schematic. For things like this, I just make sure that the exclude from bill of materials is checked, and that way it will not show up on the bill of materials, but it will show up as a footprint on the board. I also went through and added test points in a bunch of places. So on the power rails, I have these 2-pin test points that have a spot for the test point and a spot for ground. When we get to layout, we'll see how these work. They let you really easily add a scope probe onto the test point without any soldering or other tricks to get it installed. You can just poke a scope probe into this. On the Pogo sheet, I also added test points on a lot of the signals. So the SPI signals now have test points, as well as all of the points along the amplifier chain and the attenuator have test points as well. So we can use these to debug and help set values as we're developing this circuit, since we don't actually know what a lot of these values need to be yet. I also went through the schematic and did a lot of general text cleanup. So things like this, I moved so that they're not overlapping and hid some text that wasn't relevant on some of these parts, and also set everything to be horizontal. So I want to make sure that text on these isn't rotated, like that shouldn't be rotated around. Everything needs to be horizontal here. Lastly, I annotated the schematic, which is filling in all of the reference designators. To do that, you go here to the Annotate Schematic button, and you can select what parts you want to annotate, what order it should fill out the annotations, and the numbering. So I use a numbering scheme that sets the first number equal to the sheet number. So if I click annotate here and close this out, I'll show, so this is on sheet 1 and it's the 4th component on that sheet. If we go to the second sheet, everything starts with a 200 number. This makes it really easy when looking at the layout or at the board to figure out what sheet all of the parts are on and help trace back to the schematic much more easily. Before I take a design to layout, I want to make sure that we pass the electrical rules check. So KiCAD has this electrical rules checker that uses info about the pins in the symbols to say if everything is hooked up correctly. So as an example here on the regulator, all of the pins have the type of pin that they are annotated on the symbol. So we have a power input, an input. This one's also a power input. There's a power output on Vout. The switch is listed as an output and feedback is an input. There's several other types in here for different uses. So there's input, output, bidirectional, you can have tri-state, a passive pin, a free pin, unspecified, power input and output, open collector and emitter, and unconnected. So KiCAD will use knowledge about the electrical type of each pin when it runs an electrical rules check. So I can go to the electrical rules check and hit run ERC. And this generates a report of all of the errors and warnings for the ERC on this board. For our review process, some warnings are okay. Obviously, we need to take a look at all of them. Any errors need to be fixed. So if we go to just the errors here, we can see we've got things like a pin not connected that just needs a no connect symbol added to it. And we have input pins not driven by output power pins. So anything that's listed as an input power needs to be driven. Now, defining for KiCAD what actually constitutes a power net and what's providing power can be a little tricky in some situations. You can provide a power flag to the net by going into the power port and grabbing this power flag symbol. And this just tells the ERC system, this is a power net, and it has power provided from somewhere, because nothing really provides ground. I mean, you could have a connector that does it or something that's kind of your like source of ground, but that doesn't really make sense. So if we just add a power flag here, go back to the ERC, We do actually have to annotate that again. So for now, I'm just going to always reset the annotations. After we go to layout, I will change that flag, then rerun the electrical check. And that got rid of some of our errors. We also have an input pin not driven by an output pin for the 3.3 enable. So it looks like most of these are just not connected for the errors. So I'm going to go through and add some flags to all the pins that we're not connecting. The ERC goes through and puts little arrows wherever there is a issue. So I will go around the schematic, find all the arrows, and fix these as we go. These just need no connects. The 3.3 enable we don't need. We don't have a chip select on our SPI, and we're not using any of these GPIO pins. We also are not using the VREF pin on the ADC. And I'll save and go rerun. So I hit rerun here. We now have 0 errors, so that's great. It's still showing a lot of warnings. So I'm going to go review each of these and see if I want to fix it or just leave it and mark it as an exclusion. So if I take a look at these ERC errors, all of them have to do with these mounting holes. And they're all caused because we have unspecified pins connected to other pin types. So to get a better understanding of what KiCAD's looking at here, if you go into schematic setup and look at the pin conflicts map, this is the rule set that the ERC is actually using. So unspecified pins here generate warnings unless they're connected to a no connect, in which case they generate an error. So unspecified is probably not the pin type that this should have. For something like a mounting hole, it's almost always going to be connected to ground. You might connect it to power in some cases too, but it's almost never going to be connected as like a signal pin or something of that nature. So what I'm going to do to fix this is go into the symbol for the mounting hole and change the pin type to be a power input. So in the symbol editor, we're just going to open this pin up and change this to be a power input. Save that. And then now we need to update the schematic. If I run the ERC without updating the schematic, I get warnings like this that say that the mounting hole has been modified in the library, but that hasn't been updated on the schematic. To fix that, we select one of the mounting holes, and there's an update symbol option in here. Now from here, we want to update all symbols that match this library identifier, and we don't want to update any of the options or the fields. We just want to reset the symbol itself. So update here, it'll say it swapped out all 4 of those symbols for us. And now if we go back to run our ERC check and we run, we now have a completely green ERC. Now having a clean ERC is great, but I consider this just step 1 of the schematic sign-off process. I highly recommend that you have a checklist that you go through that checks all sorts of things like your symbols, making sure that they match the data sheet, having a review process for that. If you're in a company, having a second person go review all of your symbols can really help catch errors. One checklist that I really like to use as a starting point is Andrew Zonenberg on GitHub has a layout and a schematic checklist. And I'll leave a link to these down in the video description. But these walk through a bunch of things that is really good idea to check on every schematic that you do to make sure that when you get your boards back, they're going to work. When you send out a board for fab, you should be really confident that that board's going to work the first time you power it on, or that you're at least going to be able to rework anything that you have questions about to make that board turn on. You really want to avoid having to do invasive rework or having to respin boards. That's really expensive. Boards can take weeks or even months to get fabbed and get back to you. So spending a couple days even on complicated designs, going through a schematic checklist, going through a layout checklist, can really save a lot of time and money. So what I like about this checklist, it has general stuff, checking passive components. It has things like making sure your capacitors are appropriately derated, that polarized things are specified correctly if you're planning on using polarized caps. You've got like reverse voltage protection on inputs. This checklist is really thorough, so it's going to include things that may not apply to your design. For instance, since we're using the Raspberry Pi Pico module, we don't have a clock that we have to worry about. The crystal for that module is on board. So none of this is relevant to our design. So I'll just mark this as not relevant and pass by it. I do want to call out building in the ability to debug and rework your board. When there's things that you're not sure about, or they might need to change at some point, having places that you can add 0 ohm resistors to rewire the board, or places that you can attach scope probes, is super handy for being able to bring up a board without having to do complicated rework. For the first rev of a board, it may seem like overkill to add lots of 0 ohm resistors and points that you can change stuff, but it's a lot easier to just remove a resistor than to have to go in and cut a trace, for instance. You can also use these as pads if, for instance, you needed to swap 2 signals. You could take the series 0 ohm resistors out and use some small wire to bond between different pads to rewire your board. This is a lot faster than cutting a trace with an X-Acto knife, maybe having to get in there with a microscope to do it. It really is worth the time up front to help during board bring up. The last thing I need to do before we go to layout is make sure that we have footprints on all of our components. Now, I use libraries that are fully defined. So in my symbol library, every symbol that's not a generic symbol has a footprint already associated with it. If you're using other libraries, that may not be the case, and you have to go run through the footprint assignment tool. And so this lets you go through all of your symbols on your board and assign footprints to them. So you can see we already have all of this done, so there's no need to do that for this board. Once we have symbols assigned, we can open up the PCB editor and select the Update PCB button. This will pull everything from the schematic and place all of the components on the board. And so in the next video, I'll go over how to lay out and place components on the board. And then after that, we will start routing. Be sure to subscribe to follow along with the rest of the series where we will lay out the board, fabricate and assemble it, and write the firmware. Thanks for watching.